All right, we got Mr. Morrison's UIL calculator tips, part one. Although it's not really tips and tricks, the only tip is just type really fast and write your answer down. More so an introduction as to how your answers need to be. The biggest change or the biggest thing that throws people off here is how to write your answer. It's not just typing in the numbers in the calculator, writing down the answer. You have to write your answers a very specific way. So here I have a bunch of random numbers, just big numbers up in the hundreds of thousands, thousands, hundreds, all the way down to teeny tiny numbers, 0.000, and so on. All different calculators will give you your answer in different precisions, I guess. They'll round off in a different amount of decimals. Some of them will go, on and on and on. 10 places or 20 places. Some might cut it off or shorter than that. So they need a universal way of everybody rounding their answers off so that all the answers look the exact same. Now, they could tell you to round it to the nearest whole number. So if they were to do that, this number isn't really getting rounded very much. It's not, you're not even really rounding the number off. It's just still a huge giant number, 174,634. There's almost no purpose in rounding that. You could have rounded that a lot more and still conveyed the same number to whatever number you're trying to give to. If you're talking about how much money something costs, you tell me it was 174,000. That's probably good enough. I don't need to know exactly to the dollars and cents how much it was. So rounding the nearest whole number is too accurate still. At the same time, if I round this to the nearest whole number, well, that's 0. If I round this to the nearest whole number, that's 0. So whole numbers aren't the best way to go. There really is no single best way to go if you look at place value, because all the numbers can be different. When you're looking really big, like 174,000, compared to really small, it's tough to just say, cut it off at this place value and that'll be it. So what they say instead is that you have to round it off to 3 significant digits. What that means is a significant digit is like a digit of accuracy. I need to explain this number accurate out to 3 digits. So 174,634.73, the first 3 numbers there are significant digits because they tell me how accurate this can be. So 174,000. That is 3 significant digits. That is how your answer has to look. If you give too many significant digits, if you were to write this out exactly the way it is, it'd be wrong because that's more than 3 significant digits. If you give less than 3 significant digits, if you rounded it off to 170,000, that would also be wrong. Now, you might be thinking in your head, wait a minute, he didn't round right because 174,634, the 6 rounds it up to 175,000. Yes, that is correct. However, they also allow your third significant digit to be off by plus or minus 1. So 175 is the perfect correct answer, but they will also accept 176,000 and 174,000. Now, what that allows you to do is not worry about rounding off that 4th digit over to see what your 3rd digit should be. You just cut it off after the 3rd digit. 174,000 is good enough. That'll give you your correct answer. So, looking at this number, you take the first 3 digits, 174,000. Put the comma there, or you don't have to put it there. It doesn't matter either way. 174,000. The second one here, 6,704.06. Only give 3 significant digits. So the first 3 significant digits, 6, 7, and 0. Those are what I have to use. So my answer here, 6, 7, 0. Then you round off after that. 6, 7, 0, 0. You cannot put 6, 7, 0, 4. You would get that counted wrong. Can't be more than 3 significant digits. Now, 831 is an easy one. It's only 3 digits. They are all 3 significant digits because they tell the precision of this number, or the accuracy, I guess. That would just be 831. And here's where it gets a little weird. 25 is only 2 digits long. If you leave your answer as 25, it will be counted wrong because that's only 2 significant digits. You have to give your answer in 3 significant digits. Can't be more, can't be less. So actually the correct answer here would be 25.0. That 0.0 tells you how exact we're being. If you were using this in the significant digits are a big science thing later on in life. If you're doing something with science and I'm measuring the length of, I don't know, a stick. If I say it's 25 centimeters, you might think I'm rounding. You might think it's about 25. You may not know. If I say it's 25.0 centimeters, well, that shows that I was precise out to the tenths places, and it's exactly 25.0. So it does, I know 25.0 is the same number as 25, but when you add in the 0.0, it shows that that measurement is a little more precise. That's kind of the reasoning behind that. 1.7. It's a 1-digit number, I guess, because it's just 1 point something, but that 0.7 is also significant. So 1.7, but I need a third significant digit. I have to throw 0 on the end. So 1.70, those are your 3 significant digits. 0.05. Now, gotta be careful here. First few numbers, 0.0, those don't tell me how accurate this measurement is. Now they tell me how small the item is, but not how accurate my measurement is. So if I were to say 0.05, this is my only significant digit so far. I only have 1. I need to have 3 significant digits. I have to throw in 2 more zeros at the end. Now it says how precise my answer is, and 3 significant digits are 500. Now, this 0.0 does not count as significant digits, so those don't throw my answer off, but they have to be there to show what, how far out our 5 goes. You also don't have to have that leading 0. You could just say 0.0500, that'd be right also. Last one, teeny tiny number, 0.000097425. So, 0.0000, those are all insignificant. They don't show how accurate my measurement is. They just show how tiny the item is that I'm measuring. My significant digits are 974. So 974. That would be your answer. Let's look at a few calculator problems. 2.5 to the 19th power. Look at your calculator. You can type in. Let me get my mouse. 2.5 to the 19th power. Now, this gives you something you may or may not be used to seeing. 3.63798 E7. E7 is scientific notation. That's 3.63798 times 10 to the 7th power. That shows big numbers on a small calculator screen. What that E7 is really telling you to do is to move your decimal point to the right 7 places. 1, 2, 3, 4, 5, and then you have to fill in zeros in those extra spaces. You don't have to do that when you write your answer down. You can leave it in scientific notation. However, you can't use the E. You have to say 3.6 3 times 10 to the 7th. Now, your 3.63 must be in 3 significant digits. So, this happens a lot with really big numbers. You get this E7 or E15. It can also happen with really small numbers where you get E-7. That would mean you take this decimal point to the left 7 places and fill in zeros on all these gaps. So, here we're just looking at 3.63 E7. So, that would be 3.63 times 10 to the 7th. Next one, we have 5.1 divided by 7 to the 10th power. 5.1 divided by 10 to the 7th power. I lost track of 7 to the, oh no, 7 to the 10th power. 1.80547 E negative 8. So this is like what I was just talking about. E negative 8 means you take this, move it to the left, 8 spots. So 0.0000000180547, on and on. You don't have to rewrite it with all these zeros in there. Keep it in scientific notation. 1.80, 3 significant digits, times 10 to the negative 8. So 1.80 times 10 to the negative 8. We have negative 8.4 to the 12th power. Negative 8.4 to the 12th power gives us negative 1.2341 E11. So, can you imagine how that has to be written? We don't need to move the decimal out 11 places. We can write it in scientific notation, looking at these 3 significant digits, negative 1.23. Those are our significant digits. Then we have to put the times 10 to the 11. So, that's the explanation. Here, I have a whole bunch of practice numbers. So, I guess this would be, if your calculator shows this as your answer, how would you write that down? That's what I want you to think. I'm going to give you about 5 seconds per problem. So think it in your head, and then I'll write the answer down and you can see what you got. I'm not going to walk through every single problem, but I will write them all down there one at a time, just so you don't have to keep pausing the video and playing it, pausing it, playing it. So think about this number 1, 1.36987. How would you write that down if this were a calculator test? 1.36. Number 2, 265,897. 265. Those are your 3 significant digits. 0, 0, 0. Round everything off after that. Now I'm going to start just writing the answers down. You can mentally work them out as I'm going and check yourself. Two, 5, 6. Those are your significant digits there. Number 4. 2.3 is not enough significant digits. We've got to have the 0 on there. Here we have an E12. Be careful there. Don't overlook that E. Times 10 to the 12. Number 6. 35.0. Number 7. 7, 3, 2, 0. Cannot put the 1 on there. That would be too many significant digits. Negative 5.60 times 10 to the negative 8. Number 9.0000000. 6, 7, 4. Make sure you count the right amount of zeros. Number 10, 88.04. Get 8.0. Number 11, 9.86. Number 12, 3.00. 13, 3.65 times 10 to the negative 12. 14, 86,200. That's it. 15, we have 7,630. 15. Point. Now remember, you can put the leading zero out there before your decimal point. A lot of times I don't, out of habit. 0.0838. 17, 752. There's an easy one. 18, negative 9. I'll with the E. 0.14 times 10 to the 11th power. Number 19, 8.85. Number 20, it's kind of a weird one. A 1,000. So the starting with the 1, those first 3 numbers are significant. After that, we round off. So 1,006, the 6 would go away. Just 1,000. There's the end of it there. Let's look at 21. 0.00545. 22. 4.68 times 10 to the 15th power. 23. 0.986. 0 does not have to be there at the beginning. 0.986 is the same. 24. 573. Everything else rounds off to zeros. So 0, 0, 0, 0. Each 4 of those numbers, don't lose count of them, can be rounded off. You can put your commas in there, or you don't have to. Doesn't matter. 25, 66.39, 66.4. Now, try to trick you here. The answer key will show 66.4. However, that 0.4 can be up by 1 or down by 1. So 66.3 is also correct. 26, we got another E here. 8.60 times 10 to the 8th. And their final one, 27, is 1,000. That would stay 1,000. We have 3 significant digits there. Everything else rounds off. Even though it already is 1,000, it just stays a 0. It stays a 0, and that's 3 significant digits. So that is how to write your answer using significant digits. Good luck. I'll give you another video soon explaining a few more things, hopefully, and get you guys good at UIL calculator.